Hello everyone. Friends, origin of earth has always been most fascinating and interesting topic for ages. When we talk about origin and evolution of earth, a lot of question comes in our mind. There are questions like how earth originated, when was the origin of earth, what is earth's evolution, who invented earth, and there are many more questions which come in our mind. Now friends, most famous and accepted theory of origin of earth is Nebular theory or and Big Bang theory. Now Nebular theory or Nebular hypothesis was proposed by Immanuel Swedenborg, Immanuel Kant and Simon Laplace in 1700. Immanuel Kant was a German philosopher whereas Laplace was mathematician. Now when we talk about nebula, let us try to understand what exactly nebula is. So it is a rotating cloud of gas and dust that cools and contracts in the middle to form the sun and the rest into a disk that become the planets. To simplify this, or rather to say this in a layman's language, let us say that, or let us just imagine that there is a cloud of gases and dust, and it is very hot, that is it is having a very high temperature and it is rotating continuously. So due to this rotation and gravitation, what happens is slowly it forms a central core which further forms the sun. So now let us try to understand this in much detail and proper explanation. So over here friends, you can see two pictures. On the left hand side we can see the nebula which is visible in visible light, or you can say which is viewed in visible light. And on the right side we can see the nebula with millions of stars which is under or which is taken in near infrared light. Now in the left picture we cannot see the stars because of the dust, whereas on the right hand side we can see all of those stars because it is in infrared light. And as we all know that in infrared light, this light captures the heat from the stars, and that is why we are able to view these stars, otherwise which was hidden by the dust in the first picture. So this is the beautiful picture of nebula in space. Now let us go in detail of nebular hypothesis. So we can see over here that there is a big cloud of gas and dust. Okay, so you can see this over here. There's a big cloud of gas and dust, and this is nothing but nebula. And this nebula which we are seeing over here, it is of very high temperature. So Kant and Laplace, they had explained this theory in 5 different stages. So let us try to understand this theory in different stages. The first stage is collapse. Now over here what happens is this nebula which has a very high temperature gas ball, it started collapsing slowly. That is, over here it is disc shaped. It has started to become disc shaped. The second stage is spinning, where this nebula is spinning very fast. The third stage is flattening. Now you can imagine something which is rotating continuously has started taking its shape. In a similar way, how our planets have formed. By rotating continuously, it has taken a spherical shape. Similarly, over here also, it is moving continuously, or it is spinning continuously, due to which it has started flattening. The fourth part is condensation. Now over here, the fog which is there, that has formed the core and the largest mass in the middle, while the small part formed the cooling process. And the last part is accretion. The cores of smaller masses turn into planets, while most of the remains in a state of high temperature flare which is called the sun. Now over here you can see over here the nebula cloud. Okay, now this theory, basically we need to understand two hypotheses over here, that it says everything is made from nebula cloud, and secondly that the stars which were formed around 1 to 10 billion years ago came much before asteroids and planets, that is around 4.5 billion years ago. Now, also we know by this time that the sun is the biggest star. Okay, now what we need to understand is this nebula is a cloud which is made up of gases. When we say gases, it is made up of mainly hydrogen and helium gases, and it is made up of a lot of dust particles. So this, let us just understand this. So over here there is helium, there is and then there is dust particles. So all of these, they are continuously rotating. So this is hydrogen, helium and dust particles. Now everyone knows about the centrifugal forces. So when they are rotating continuously, what exactly happen is that the low density elements, now we know that low density elements are hydrogen and helium, that will come in between over here, and the higher density elements will be at the core, that is at the surfaces over here. So what will happen is, due to collision and friction at the core over here, we can see a formation of sun, and around this there will be formation of disc shaped. Okay, so slowly all this disc will start forming like this, and in between we can see the sun. Slowly this disc, when it is moving, it will form its own orbit, and that is nothing but different planets which are there, that is going to form over here. Okay, whereas in between we can see the sun. So sun is the biggest star, whereas rotating over here, there will be many smaller nebulas which will be rotating, and slowly, similar like this sun, the smaller clump of clouds with further friction and further collision, they will form disc-shaped cloud, and this due to accretion at the end, that is the fifth step, accretion, due to which there will be formation of planet in different layers of the disk, and that is how the planets have been formed. Okay, so that is nebula theory, and it is one of the most accepted theory of origin of Earth. Now let us try to understand this with the help of a video which will explain it in much more better way.
Our solar system is the region of space which falls within the gravitational influence of our sun. The solar system is thought to have begun forming about 5 billion years ago from a giant spinning cloud of gas and dust. The core of this cloud grew under the influence of gravity and became denser and hotter. As material fell towards the growing core, the cloud increased in speed and flattened into a giant spinning disk. Eventually, the increasing temperature generated enough energy to trigger nuclear fusion. This fusion marked the birth of our sun. The lighter gas was swept far out into the solar system, leaving heavier, rockier material and metallics with high melting points nearer the sun. Molten metal and dust particles stuck together to form clusters, which in turn stuck together to form rocks. Mutual gravity caused these rocks to come together, eventually to form planets. In the hot inner regions of the solar system, rocky planets with metal cores were formed. In the colder outer regions, things were different. Further from the sun, temperatures dropped. Water vapor condensed and turned to ice. This ice, combined with the vast amounts of gas blown away from the sun, meant there was a lot more material here than in the inner regions. As huge cores of ice and metal grew, The gases swept away at the sun's birth were attracted through gravity. When the accretion of most of the ice and gas was complete, we were left with the gas giants. The solar system as we know it is around 4.6 billion years old. It's looking pretty good for its age.
It comprises countless galaxies, each one containing numerous stars. Around some of those stars, there are planets, just like those that orbit our own star, the Sun. The nebular hypothesis is the most widely accepted explanation for how the Sun and planets in the solar system may have formed. When our solar system was first created, all that was thought to have existed was a cold, spinning cloud of gas called the solar nebula. The nebula resulted from an uneven distribution of gases throughout the universe. As the gravitational pull began to condense the gas toward the center, the speed of the rotation increased. This caused the cloud to flatten, creating an accretion disk. Matter continued to collect as the growing force of gravity drew it toward the center. Eventually, the gas warmed from the increasing pressure. As the mass further increased, the gravity also increased, and as a result, the temperature continued to rise. A ball of hot gas formed in the center of the accretion disk, creating a protostar, also known as the Sun. Finally, when enough gas gathered in the center of the protostar, the pressure generated enough heat to fuse the atoms, forming a star. Outside the star, matter was forming into clumps of gas, dust, and rock, which created protoplanets. These protoplanets continued to grow as they trapped material in their gravitational fields. Because the protoplanets all formed from the same cloud of gas and dust, they travel around the Sun in the same direction and in the same plane. The nebular hypothesis also explains how the planets are arranged. The heat and solar winds caused by the Sun swept the lighter gases farther out into the developing solar system. This is why the rocky terrestrial planets, Mercury, Venus, Earth, and Mars, are located closer to the Sun. The gas giants, Jupiter, Saturn, Uranus, and Neptune, formed in the cooler outer region of the solar system. The solar system continued to evolve even after its initial formation. Large asteroids slammed into planets, and the planets themselves differentiated into layers as they slowly cooled. Although the nebular hypothesis cannot be directly tested, it is a useful description for how a solar system forms. It explains why planets and the star they orbit usually spin in the same direction and lie in the same plane. It also explains the arrangement of the planets, with the rocky planets nearest to the Sun and the gas giants farther away. The next time that you look at the stars twinkling in the night sky, imagine new planets forming using these very steps.
So, thank you so much. I think we are more clear with this concept, that is the nebular hypothesis. Thank you, everyone.